Hello, science students. Today's lesson is about forces, motion, and Newton's first law of motion, which is sometimes referred to as the law of inertia. Let's start off by thinking about force. What do you think of when you hear the word force? Many of you might think of Star Wars. A force is not the same thing as the force, but they act in kind of similar ways. A force is easiest to think of as a push or a pull acting on an object. That would be a wonderful definition for you to write down in your notebook. A force is a push or a pull that acts on an object. There are lots of different types of things that are forces. You can have an electrical force. You can have a magnetic force, and these two can work together in what's called an electromagnetic force. You can have nuclear forces that can be either weak or strong. You can have gravity as a force, so is friction. And then there's applied forces. There's also things like tension and compression that could be examples of forces. But we're just going to focus on ones that affect motion of our everyday type of objects. All motion is caused by some sort of a force. You cannot have motion if there's no force applied to the object. And gravity, friction, and applied forces are what affect our everyday objects, the easiest examples to think of when you think of forces and motion. A good definition for motion might be a change in an object's position over time. That might also be a wonderful thing to write down in your notebook, that motion is a change in an object's position over time. You might want to have something more than just movement as a definition for motion. Whenever something changes the direction or the speed of its motion, it's because a force was applied to that object. Forces can make an object start to move. It can make one stop. It can make it change direction. It can cause something traveling in a straight line to turn to the left or turn to the right or pop up vertically or drop. Whenever that speed or direction changes, it's called acceleration. You're probably familiar with that term, acceleration. For instance, as you're riding in a car and the car accelerates, the speed increases. You get going faster in the car. Forces in motion affect everyday objects. Let's take a look at some forces and how they change the motion of a rider on a scooter. Let's break it down. The first thing you have is an applied force that moves the rider to the right. They gain this applied force by either dropping in on the other side of the pool or pushing off with their foot. Those would be applied forces where gravity applies to it, causes it to move. The foot pushing on the ground and moving the scooter would be an applied force. And you can see it's moving from the left to the right. As that scooter goes up the ramp, a force from the ramp is applied to the scooter and to the person, and that causes them to move upwards, and their direction changes, and they start to move vertically as opposed to horizontally. In the next section, they reach the top of their height, and they start to fall back down to the ground. This is a force called gravity pulling them back to the ground. As they land, friction acts against the direction of their motion. That friction helps the wheels stick to the ground and not slide out from under the person, but it also slows down the speed ever so slightly. Each of those forces had an effect on the scooter and the rider's direction and speed. A change in their motion is caused by a force. We measure a force with a unit that's called the Newton. And that's because Sir Isaac Newton was the one who really did a lot of work related to our understanding of forces and how they work. 1 Newton is the amount of force it takes to move 1 kilogram, 1 meter per second per second. So to change its acceleration by a meter per second of a 1 kilogram mass. We represent our forces with an arrow. Just as you saw in those previous examples with our scooter, arrows show the direction of the force. Forces also have size besides direction. We use the arrow to point in the direction of the force, which way is it being applied, and smaller forces have smaller arrows, bigger forces have bigger arrows. Sometimes there's more than one force that acts on an object. If both forces are acting in the same direction, they are added together. In this example, you can see that there's 2 people pushing a dresser. One person is pushing the dresser from the top, and another one is pushing it from the bottom. On the left-hand side of the picture, you can see that they have their own arrows representing their own force and the direction that they're applying. In the second picture, you can see that those 2 forces have been added together to make one big arrow showing a larger force of their 2 smaller forces combined. When forces act in opposite directions, you have to subtract the smaller force from the larger force. This is what we call the net force. Here you can see 2 dogs playing tug of war over a rope toy. There's that smaller dog who looks kind of like a terrier of some kind, maybe a Boston Terrier, and it's pulling on that rope with a force of 10 newtons moving to the left. The dog on the right looks more like an Australian Shepherd or Australian cattle dog, and it is pulling on the rope with a force of 12 newtons moving to the right. The dog on the right, the cattle dog, has a larger force than the terrier, and so you subtract the 10 newtons of the terrier moving to the left from the 12 newtons of the Aussie moving to the right, and you end up with a net force of 2 newtons to the right. That Australian Shepherd is going to win this tug of war because it has a larger force. Net forces explain the direction and motion that we see on an object with more than one force that's applied to it. The net force goes the direction of the larger force. Whenever we have an object that's moving, its forces are what we call unbalanced. One of those forces is stronger than all of the other ones, and it's moving in that direction. But objects that are stationary or are not moving also have forces acting on them, but they're balanced in opposite directions. Just like if you had a perfectly balanced tug of war team, the rope would not be moving because the forces on each side of center are balanced. So moving objects have unbalanced forces. Stationary or not moving objects have balanced forces. If you understand these basic principles about force and motion, then you're ready to take a look at Newton's first law of motion. Newton's first law of motion says that an object at rest will remain at rest, and an object in motion will remain in motion at a constant speed unless it's acted upon by an unbalanced force. So essentially, it takes a force to move an object, and it takes a force to change the motion of an object. There's a force to start movement. There's a force to change movement. It takes a force to stop movement. This brings us to our next important term, inertia. It's a tendency to do nothing or to remain unchanged. Again, this definition might be something important to write down. Inertia is the tendency to do nothing or to remain unchanged, which is essentially what Newton's first law says, is that objects have inertia. Objects that are not moving don't want to start moving. They want to do nothing. They want to remain unchanged. Items that are moving, they have inertia. They want to continue moving. They don't want to change their movement. In this example of inertia, you can see a motorcycle rider who is in the middle of crashing their motorcycle. As their motorcycle is driving into the tire barricade, a force acts on the motorcycle, stopping its motion. That force is acted on the bike and not on the person. So the person who was attached to the bike, sitting on the bike, still had inertia. They wanted to continue their movement, and no force had acted on them. And so as that force hits the bike's motion is stopped, but the person's inertia continues moving forward, and the rider ends up flying off of their bike and continuing to the right until they complete their crash. One important idea about inertia involves an object's mass. The larger the mass of the object, the greater its inertia, or the more it takes to change its movement. If something has a smaller mass, it takes less force to begin moving the object. If an object has more mass, it takes a greater force to move that object. And that's what you see in this visual here. You have two buckets hanging. It's got one that's empty, and the other one is filled with sand. It takes a greater force to push and move the bucket that is filled with sand than it does to push or move the empty bucket. Thank you for your time. You are free to rewatch this video as many times as you need. Good luck, and I hope this helps you understand forces and motion, and Newton's first law of motion, the law of inertia.